Hello, in this lesson we're going to be talking about primes and prime decomposition. Our learning goals will be to identify prime numbers and to break composite numbers down into a product of prime factors. Let's begin by going through some definitions. So a positive whole number that has only two distinct factors, one and itself, is called a prime number. And a number that has more than two factors is called a composite number. Now, there are two exceptions to this rule, which are 0 and 1, which are neither prime nor composite numbers. And we're going to see these later on. But let's now go through some examples. So 7 is a prime number because its only factors are 1 and 7. So therefore, because it only has two distinct factors, 1 and itself, we call it a prime number. 10, on the other hand, is a composite number because its factors are 1, 2, 5, and 10. So because it has more than two factors, we call it a composite number. Let's now do a task together. What I want you to do is write all of the factors of the numbers from 1 to 7 and identify whether they are prime or composite numbers. So pause the video and give it a go. So let's now give it a go together. So how many factors does 1 have? Well, it just has 1, which means it doesn't have two distinct factors, and it obviously doesn't have more than two distinct factors, which means that it's neither prime nor composite. And if you remember back, that was one of our exceptions. The other one was 0. 2, what are the factors of 2? Well, 1 and 2. So it has two distinct factors, 1 and itself. So that makes it a prime number. 3, the factors will be 1 and 3. So 1 and itself, which makes it a prime number. 4 has 1, 2, and 4. So because it has more than two distinct factors, that is going to mean it's a composite number. 5 has 1 and 5. So 1 and itself, that makes it a prime number. 6 has 1, 2, 3, and 6. It has more than 2, and therefore it is a composite number. 7 has 1 and 7, which means it's a prime number. Perfect. Hopefully you are therefore able to identify between prime and composite numbers. Let's now move on to prime decomposition. Every composite number can be written as a unique product of prime factors. That is to say, every non-prime number can be written as a collection of primes multiplied together. For example, 10, which is a composite number, can be broken down into 2 times 5, which are both prime numbers. 21, which is a composite number, can be broken down into 3 times 7, which are both prime numbers. 18, which is a composite number, can be broken down into 2, 3, and 3, which are all prime numbers. And a better way to write that would be 2 times 3 raised to the power of 2. So as you can see here, composite numbers can be broken down into a collection of primes multiplied together. Now, how can we get these prime decompositions? And that's where we're going to learn about factor trees. We can use factor trees to find the prime decomposition of any composite number. Start with the number at the top, then break it into factor pairs until you have prime factors. So until you have prime numbers. So we're trying to get our prime decomposition. Another way we could say this is that we're trying to get it into prime factor form, and you're going to see what I mean very soon by that. But let's now get stuck into prime factor trees, and I really enjoy doing prime factor trees. They're oddly satisfying. So we have 24, and I can break that down into 12 and 2, because 12 times 2 is 24. Now I'm going to grab my red pen and I'm going to circle 2 because it's a prime number, which means that this cannot be broken down any further. It's going to stop here. But I have 12, which is a composite number, so that means it can be broken down more. It can be broken down into 6 and 2, because 6 times 2 is 12. I'm going to circle this 2 because it is a prime number. Then I'm going to come to 6, that's a composite number, so I'm going to break it down into 3 and 2. I now am going to circle these, circle, circle, and now I have my prime decomposition. 2 times 2 times 2 times 3. So my prime factor form is going to be 2 times 2 times 2 times 3. And we can double check that this is the case. This should equal 24. Well, 2 times 2 is 4, times 2 is 8, and 8 threes are 24. So it absolutely checks out. And there's actually a better way we could write this. We could write that this is 2 raised to the power of 3 times 3. So this is what we call our prime factor form. Now, if we come here, so this is just what we just did. Now, prime factor form is 2 raised to the power of 3 times 3. But if we look up here at this note, there are multiple ways to organize a factor tree to get to the correct prime decomposition. So in other words, I could break down this 24 in different ways. I don't necessarily have to break it down into 12, then 2, then 6 and 2, and so on. Instead of doing that, let me break it down in a different way. Let me go 8 and 3, because 8 times 3 is 24. So I could now circle this because that's a prime number. My branch will stop there. 8 can be broken down into 4 and 2. I'm now going to circle that. Whoops. My pen gave up on me. I'm going to circle that. Then I'm going to circle my 4, 2 and 2. I'm going to circle them. So that means my prime factor form will be 2 times 2 times 2 times 3. 2 times 2 times 2 times 3, which is what we found over here. So this is just to prove that there are multiple ways to organize a factor tree. But let's now do some more examples. So you should pause the video and see if you can do these. So find the prime decomposition of the following composite numbers. So let's begin with 30. 30 can be broken down into 3 and 10. 3 is a prime number. Whoa, my pen is freaking out. There we go. 10 can be broken down into 5 and 2, which are both prime numbers. So I can circle both of those. I can circle 5 and I can circle 2. So that means that my prime factor form is going to be 2 times 3 times 5, which should equal to 30. And we can double check this. 2 times 3 is 6, and 6 fives are 30. So that checks out. Let's now go on to 48. 48 can be broken down into 2 and 24, because 2 times 24 is 48. 2 is a prime number, so I can circle it. I then need to break down 24 because it's a composite number. It can be broken down into 12 and 2. Now I'm going to circle my 2 because it is a prime number. Now I'm going to break down 12, and I'm going to break it down into 3 and 4, and then I'm going to break down this into 2 and 2. Then I'm going to get my red pen and circle all my primes that I have created. Now I'm going to gather all my primes together. So 2 times 2 times 2 times 2. So that's 2 raised to the power of 4 times 3. And again, I can double check that this equals 48. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And 16 times 3 is 48. So that works. Let's now go into 100. So 100 can be broken down into 10 and 10. 10 times 10 is 100. This can be broken down into 2 and 5, because 2 times 5 is 10, and so too over here. So that means 2, 5, 2, 5. So I could write that as 2 raised to the power of 2 times 5 raised to the power of 2. And this makes sense because we know that 5 squared is 25, 2 squared is 4, and 4 times 25 is 100. So that checks out. Perfect. Now that ends today's lesson. The homework that you need to complete for this content is exercise 3D and exercise 3F. Hopefully this was helpful to you. And let's now just review what we did today. So what we did, Our learning goals were to identify prime numbers, which we did, and to break composite numbers down into a product of prime factors. Hopefully this was helpful to you, and good luck in completing your homework.